If you have been watching my videos or in general from any other creator in the same niche, you must have come across this term called neural networks. I am apologetic because this is something very elemental and I should have covered it beforehand. It is such an important video that until you don't know what this term means, there is no way you can understand the developments in the world of AI. I have put on my teaching gown, so let's begin. Let me start with a basic question. Can you tell how we can represent any entity, happening, or object across the universe in an understandable notation? If you know it, great! Understanding neural networks will be much easier for you. And for those who don't, let me put it into simple words. Almost everything in our universe, in the language of mathematics, is a function. Need examples? Consider the number of dust particles in the air of a particular region. Now, the number of contaminants in the air of a region corresponding to its time is a function. And all of us know that function. It is called AQI, or Air Quality Index. Now, I'm not going to jump into how it is calculated because there are better people on the internet who can tell you how it is calculated and what equipment is used to aid the process. But what I am trying to establish is how these functions are everywhere around us. If you need more examples, consider sound. It is a wave that is plotted corresponding to the x-axis of the Cartesian plane, and the power or amplitude of this wave is represented on the y-axis. We can judge its frequency by seeing how many times a complete cycle has occurred in unit time, that may be in seconds or in minutes, or by just calculating the time period of a wave and taking its multiplicative inverse. Similarly, light, speed, movement, GDP, density, and area are all of these terms that we use in our daily lives, and they are functions. They explain how one quantity changes corresponding to the other. And the most common way to represent a function mathematically is y equals f of x, where y is the independent variable and x is the dependent one. We may represent a sinusoidal wave as amplitude equals sine times time, considering the wave amplitude as a dependent variable, changing with time sinusoidally. You must be wondering, okay, if we have the power to map almost everything in the universe, then what's the fuss about neural networks? Well, neural networks are our superpower that helps us create new functions. I will repeat this again. Neural networks help us create new functions. But how? For that, we need to jump into a black box. Yes, it may sound dark and full of uncertainty, but this is the best way of explaining what neural networks do. In our universe, there are a lot of happenings that have a certain outcome. We know the inputs or stimuli that are required to produce such outcomes, and we know what the outcomes are going to be. And mathematicians love to call this situation a black box. Like, consider a bunch of signals that go into a certain piece of equipment that return different signals after processing. For example, we supply an analog signal to an analog to digital converter. In return, we get digital signals that any transistor-based equipment can analyze if it falls within its limits. Consider the AD converter here as a black box, and imagine that we did not know what was converting these analog signals into digital ones. Yes, I know that AD converters were made way before the term neural networks hit our eardrums. But if we consider this as a problem and try to find what phenomenon is happening during this conversion, we would use neural networks. This is basically how there are gazillions of things happening in our universe and similarly in the world of computing, resulting in new things. But we don't know how till we jump into neural networks. So how does this magic happen? How do things come under our grab that we barely knew about beforehand? For that, let's see how neural networks work. Imagine you're a baker and you've been baking the same types of bread for years. You've got your classic white loaf, your hearty whole wheat, and your sweet cinnamon swirl bread. One day you start wondering if you could create a completely new and unique bread flavor that no one has ever tasted before. You ponder over this challenge, and then it hits you that why not enlist the help of a magical ingredient mixer that can combine various flavors in unexpected ways. This magical mixer, obviously our neural network, has the power to take your existing bread recipes and mix their flavors in ways you'd never thought of. Here's how it works. You provide the neural network with all your tried and true bread recipes, along with the different ingredients and quantities you've used. The neural network then gets to work. It starts by randomly mixing and matching these ingredients, creating some bread recipes that might sound strange or unusual at first. like blueberry garlic bread or rosemary chocolate swirl bread. Now, not all of these experiments will be successful. In fact, most might taste terrible, but that's okay, because the neural network is designed to learn from its mistakes, just like how you as a baker learn from the not-so-great loaves you baked. The neural network takes note of which ingredient combinations led to delicious new flavors, and which ones resulted in disasters. Over time, after countless rounds of experimentation and learning, the neural network starts to get the hang of it. It begins to understand which ingredients complement each other in surprising ways. It might discover that a pinch of sea salt in your cinnamon swirl bread actually enhances the sweetness, or that a touch of honey in your whole wheat loaf adds a delightful twist. Eventually, the neural network presents you with a breakthrough, a recipe for a completely new and amazing bread flavor that you could have never imagined on your own. Maybe it's a fusion of mango and jalapeno that creates a sweet and spicy explosion of taste. Or perhaps it's a mix of cardamom and orange zest that transports your taste buds to a whole new realm of flavor. Now, if we hop out of your bakery and enter OpenAI's headquarters, we see a similar kind of trend, leading us to the question, how neural networks work in the field of AI. Think of AI researchers as modern-day explorers, always on the lookout for new and innovative ways to solve complex problems. Just like our baker friend used a neural network to come up with unique bread recipes, AI researchers use neural networks to come up with new and innovative solutions to challenges in various domains. For example, let's consider the field of image recognition. Imagine you want to build an AI that can look at pictures of cats and dogs and accurately classify them. You start by feeding the neural network thousands of images of cats and dogs, each labeled with the correct classification. The neural network begins its creative journey. At first, the network's guesses might be way off. It might mistake a cat for a spaceship or a dog for a pizza. But just like our baker, the neural network learns from its mistakes. It adjusts its internal ingredients or weights and connections and tries again. Over time, it starts recognizing patterns in the images, the shapes of ears, the arrangement of fur, and so on. Through countless rounds of trial and error, the neural network becomes better and better at accurately distinguishing between cats and dogs. It's like the network is discovering its own unique combinations of visual features that signify cat or dog. Eventually, it becomes so good that it can even identify specific breeds of cats and dogs it hasn't seen before. This approach isn't limited to image recognition. It's used in natural language processing, where neural networks learn to generate human-like text. Just like our baker mixed ingredients to create unique bread recipes, these networks mix words and phrases to generate coherent and contextually relevant sentences. In the medical field, neural networks can help in diagnosing diseases by learning from a vast database of medical images and patient data. They can find subtle patterns that human doctors might miss, leading to earlier and more accurate diagnoses. In the world of self-driving cars, neural networks learn to navigate complex environments by observing real-world driving scenarios. They learn to differentiate between pedestrians, other vehicles, and obstacles, much like our baker's network learned to differentiate between different types of bread ingredients. After all this explanation, I think now I can finally define neural networks. These are machine learning models that are built using principles of neuronal organization, discovered by connectionism in the biological neural networks constituting animal brains. I knew that the definition would be the trickiest part, so I saved this for the end. Now, if you manage to understand how they work like our brain, this definition would become a piece of cake for you. Imagine you're learning to recognize different faces: your friend Sarah, your cousin Alex, and your favorite celebrity, for example. Your brain doesn't just memorize every tiny detail of their faces. Instead, it looks for distinctive features that help you tell them apart. Similarly, neural networks work by breaking down complex tasks into simpler steps, just like our brains do. In your brain, you have billions of neurons that communicate with each other through connections. Neural networks mimic this with nodes. Each node represents a simplified version of a neuron, and these nodes are organized into layers. When you see a face, your brain processes it step by step. First, it might identify basic shapes like eyes, nose, and mouth. Then, it combines these shapes to recognize the face. Neural networks follow a similar process by having multiple layers of nodes that gradually analyze the input data, just as your brain picks out distinctive features of faces, like the shape of someone's eyes or the curve of their lips. Neural networks identify features in data. For instance, when recognizing handwritten digits, they might learn to detect loops and straight lines. Your brain gets better at recognizing faces as you see more of them. Neural networks learn by being exposed to numerous examples too. The more images of cats and dogs they see, the better they become at distinguishing between them. No wonder why data is the new currency. The tale doesn't end here. If you meet someone with a unique facial feature, your brain can still recognize them as a person. Neural networks can also generalize from what they've learned and identify new patterns they haven't encountered before. And the superpower this machine learning inherits from a human brain is its ability to process things in a parallel manner. Your brain processes many things simultaneously. Neural networks operate in a similar parallel manner, with multiple nodes working on different parts of the data at once. I hope this video made things easier for you to understand. Subscribe to Innovella for more blues from the world of AI. I try to make things easily understandable, and I have made a video on the 7 stages of AI. So if you want an understandable explanation, click on the video link popping up.